Hey everyone, welcome back. In this video, we're going to set up our Unity project and start laying the foundation for our turn-based RPG system. Now, before we do anything else, you need to use a compatible Unity version. And you must be using Unity 6.0.6CF1 or Unity 6.3 or any later version. These versions include the updated Unity AI Assistant integration, which is required for everything we're going to be building in this course. Once your Unity version is ready, go ahead and create a new project. A standard 3D template is perfectly fine as we don't need anything advanced at this stage. And name it whatever you want. I named mine AI Turn-Based RPG Combat System, and go ahead and open it up. I already have mine open, so I'm going to just pull it up. And instead of immediately jumping into scripts and systems, we're going to start by planning the entire structure of the game using Unity AI's Assistant's plan mode. This is important because it helps us define the architecture first before writing any code. And plan mode lets us describe the full goal of our game, and the AI will break it down into systems, components, and implementation steps. Now let's open up the AI Assistant panel, and we're going to create a new conversation for our project and switch into plan mode. And we're going to enter something like design a simple turn-based RPG combat system for Unity. And we're going to have to give him a little more details in this prompt because we want our plan to be as thorough as possible. So we're going to continue including core gameplay systems. So include core gameplay systems such as character, stats, turn management, action selection, damage calculation, and a basic UI. And we're going to give him some extra tips or some extra guidance to give us the best plan possible. So let's give him this extra step, which is keeping it modular. So keep it modular and suitable for iterative developments. Now, I'm going to run this prompt, and I'm going to come back after it finishes generating the plan so we can analyze it together and see what the AI gave us. While it's generating, keep in mind that this step is more important than it looks, because a good plan will make everything later significantly easier to build and debug. Alright, so now that the plan has finished generating, there's something important to understand about plan mode. When you see the option to approve and run the full plan as a task list, it might be tempting to just execute everything at once. But generally, you would want to avoid doing that because for systems like this, it becomes too heavy and too hard to control what's happening. And you will lose the ability to properly understand and debug each part of the setup. So instead, we're going to use a more structured approach. We'll treat this plan as a blueprint and then build everything step by step, manually guiding each phase of the implementation. That way, you actually understand how each system is created instead of everything being generated all at once in the background. Now I'm going to open up the plan quickly and go through what it generated. Alright, so I already have it open here, and what Unity AI Assistant gave us here is actually a really solid foundation. Because at the top, we have the project overview, and it confirms the core idea, a simple turn-based RPG combat system, single player versus AI, and inspired by classics such as Final Fantasy, Pokemon, and Dragon Quest. So that aligns perfectly with what we want. And then we move into game mechanics. This outlines the full combat loop. Combat start, player turn, action selection and execution, enemy turn, and at the very end we got evaluation for any win and loss conditions. This is the core loop we're going to build first because everything else depends on it. And it also mentions input methods such as mouse and keyboard, but for now we'll mainly focus on UI buttons to keep things simple and clean. And the next section is UI, which defines what we need visually. So an action menu with buttons such as attack, defend, and skill, and a HUD for player and enemy status bar, namely the name, HP slider, and the character status. And a combat log to display actions during the fight. So we have a clear separation between gameplay logic, presentation, which is exactly what we want in a proper Unity architecture. Now, we already have the key assets and context. We also have the key assets and context. And this is essentially the AI predefining our script structure. So we got scriptable objects for stats and actions, this and this. And we have a combat manager to control the flow. And we have a combatant class for a runtime state of the combatants, a UI controller. This is the one, combat UI controller.cs, and a damage calculator utility. And this is pretty standard and a solid setup for a turn-based system. And the next step is the next section is the implementation steps. And this is where the plan breaks everything into phases. Phase 1 is data and core entities. Phase 2 is combat flow and state machine logic. And phase 3 is UI and interaction wiring. Phase 4 is polish and feedback systems. This is actually very useful because it gives us a clean build order to follow. 1, 2, 3, 4. And we're not going to skip ahead or build everything at once. We'll follow this structure step by step. And finally, we have testing and edge cases. This includes things like verifying damage calculations, ensuring death triggers at 0 HP, and handling status effects correctly. And also making sure the UI stays stable during state changes. This is the kind of stuff that prevents bugs later, so it's good that it's already included. And overall, this is a strong foundation, but we're not going to execute it all at once. We're going to treat it as a blueprint and then build it step by step in Unity so everything stays clear, controllable, and easy to debug. In the next video, we'll start with phase 1, setting up our data structures and entities using scriptable objects and building the core foundation of the combat system. Thank you for watching, and I'll see you in the next one. Hello everyone, welcome back. In the previous section, we created our Unity project and used plan mode to generate a development roadmap for our turn-based RPG combat system. We reviewed the plan, broke down the different phases, and established the overall architecture that we're going to follow throughout the rest of the course. In this section, we're going to start implementing that roadmap by building the foundation of the entire combat system. We'll begin with our data layer, creating the systems that will define characters, stats, and combat-related information. So according to the roadmap, the first thing we need to build is our core data architecture. That includes the character stats, combat actions, and eventually the combatants that will participate in the battle. And for this, we're going to use scriptable objects. Now, if you've worked on RPGs before, you've probably seen scriptable objects used extensively. They allow us to store reusable game data as assets inside of the project. So instead of hard coding values directly into scripts, we can create assets that define things like a character's health, attack power, defense, and other properties. This makes the project easier to maintain, easier to balance, and much more scalable as the game grows. Since we're following the roadmap step by step, the first asset we're going to create is our character stats scriptable object. And this will become the source of truth for the base stats for every combatant in our game. Now, so let's open our Unity project and head over to Agents mode. Now, we're going to select the previous chat to follow through with our context. And I'm going to write a short prompt that creates our scriptable object. So create a character stats SO scriptable object for the game. You can define the game again and again for him, but this won't make a difference since we already established the context of the project. And so we're going to remove it and write include fields for character name, max HP, attack, defense, speed, and the sprite portrait. Now I'm going to run this prompt. And once the AI assistant finishes generating the code, we'll review the results and continue building the rest of our combat system. Alright, so the generation has finished, and the AI created our character stats scriptable object exactly as we requested. If we go ahead and analyze what we have here, the fields for character name, portrait, maximum HP, attack, defense, and speed are all there. These are the core attributes that will define a combatant's base statistics. And it also went a little further and added a combat action scriptable object for us. And this wasn't part of the exact prompt, but it's a logical addition since combat actions are another piece of reusable data that we'll need later. And so in this case, that's actually a useful suggestion from the AI. And I've also noticed that it's part of the task list that we created earlier, so it's moving based on this task list, but it's not going all through it at once. So that's also a good thing. And the important thing to understand here is that these assets don't represent a character that's actively participating in combat. They simply store data, and a character's current HP, temporary buffs and status effects, and other runtime values should not live inside these scriptable objects. That information belongs to our combatant classes. So now that our data layer is starting to take shape, we can move on to the next part of the roadmap, which is creating the runtime combat entities. Now, if you go ahead and check the plan again, we need to implement our combatant script to hold the runtime states. So these are the objects that will actually participate in battle, and they'll read their base stats from the scriptable objects that we just created, but they'll maintain their own runtime state during combats. Now let's go back to agent mode And this time I'm going to enter the following prompt. Create a combatant base class. It should use character stats SO, so we're always gonna have to link everything together. Data, track current HP at runtime, support taken damage, healing, death checks, and expose basic combat methods. Now, let's run this and see what the AI generates. Alright, so the generation has finished, and this is exactly the kind of result we're looking for. The AI created a base combatant class along with separate player combatant and enemy combatant subclasses. Looking through the generated code, first, it's correctly initializing runtime health from our character stats SO, as you can see over here. And this means that we're maintaining a clear separation between static data and runtime state, which is a very important design principle for RPG systems. And it also includes health tracking and taking damage functionality, healing functionality, and death checks. These are fundamental systems that every combatant will need, regardless of whether it's a player, enemy, boss, or any future character type. And I also like the regenerated events for our health changes, as you can see over here. And also for death notifications. Let me just remove this agent over here. Those will become extremely useful later when we start building our user interface. Instead of the UI constantly checking values every frame, it can simply react whenever something changes using these actions over here. And the generated code even includes support for a defending state. And this wasn't something we specifically asked for in this prompt, but it aligns with the roadmap and gives us a nice foundation for future combat mechanics. As you know, a lot of RPG turn-based combat include the choice of defending or guarding. And the subclasses are simply not implemented yet, which we will do in the next sections. So at this point, we've successfully completed the first major objective of Phase 1. We now have our data assets and our runtime combat entities. If we look back at the roadmap, the next major item is the combat flow itself. And before we can build a turn system, we need something responsible for coordinating combat. So the next section, we're going to be building the combat flow. And this will eventually become the central controller for this entire battle. It will handle turn states, determine whose turn is it, and manage combat flow, and coordinate interactions between players, enemies, and the UI. Thank you for watching, and I'll see you in the next one.